All right, you can see we're going to identify the different parts of the chemical equation, categorize chemical equations today. We'll hold off on balancing these equations until our next lecture. First thing I want to point out to you is that all chemical reactions have two parts. You have your reactants. That's the material you start with before the chemical reaction occurs. Those are always written on the left side of the arrow. Then you have your products. Your products are always written on the right side of the arrow, and that is what is a result of the chemical reaction. And you can see this example here. We have calcium carbonate, which is being broken down into calcium oxide and carbon dioxide. Now, the rest of our lecture today is going to be looking at the 7 types of chemical reactions. So with our lecture today, what I'd like to point out to you are the key signs that you're dealing with each type of chemical reaction. The first type of chemical reaction we're dealing with here is synthesis. The key identifier for a synthesis reaction is that synthesis reactions always end up having just one product. Okay? You take 2, 3, even possibly 4 reactants and combine them together to just make one final product. Your example here, okay, if we take sodium metal and react it with a chlorine gas at a high temperature and pressure, we can force those two to bond together and produce sodium chloride. Again, is this reaction balanced here? Okay, no. We've got 2 chlorines over here, so technically we need a 2 out front there and a 2 out front there. Again, don't worry too much about the balancing chemical equations. We'll talk about that with our next lecture. Now, synthesis reaction and decomposition reactions are opposites of one another. Synthesis reactions, we bring everything together to form one product. With a decomposition reaction, we start with just one reactant. Okay? We have just one reactant that'll get broken down into 2 or more products there. And the classic example of a decomposition reaction is the breakdown of water. Okay, the decomposition of water, where we take water and break it down into its elemental forms, hydrogen gas and oxygen gas. Any questions about those? All right, moving on. The third and fourth types of reactions here, single replacement and double replacement. All right, your first type of reaction that you're dealing with here, single replacement reaction. The key to a single replacement reaction is you're going to start with one element and one compound. Now, the key to knowing what the element switches places with is to remember that like charges replace like charges. For example, if I take this silver nitrate compound and we break it apart, we know the silver is going to have a positive charge and the nitrate is going to have a negative charge. Now, if copper were to want to bond, okay, we know from last unit that copper is always going to be a +1 or a +2 charge here. Yes? Okay. The +1 or +2 doesn't really matter to us. All that matters to us is that when copper forms a bond, it has a positive charge. Therefore, the copper is going to switch with the other part of the compound that also has the positive charge. So we see the copper and the silver switch places. That's why the silver is by itself and the copper is now bonded with the nitrate. Like charges replace like charges. Okay, if we wanted to do another example of what this would look like. Okay, let's say we had chlorine gas reacting with aluminum fluoride. Okay, we take and break the aluminum and the fluorine apart. We got 3 fluorines, each of which are -1, and the aluminum, which is 3 positive. If chlorine were to enter into an ionic bond, what charge would it get? A -1, right? Okay, so what's the chlorine going to switch places with? The fluorine. Remember, like charges replace like charges. So the chlorine and the fluorine are going to switch places. We're left with a fluorine by itself and some kind of combination of aluminum and chlorine. Now, when fluorine's by itself, what does it need? 2. Why? Yeah, because it's part of the Brinkelhoff. Okay? Then, aluminum is 3 plus, chlorine is 1 minus, so what do we need to do to get that compound to balance out? We need 3 chlorines, AlCl3. Questions on that? All right, if we go back up here, we look at the next type of reaction that we have, a double replacement reaction. The key to a double replacement reaction is that you start with 2 compounds. These double replacement reactions are most commonly your precipitate reactions. Okay, you get the like charges switching places with the like charges, and one of these compounds over here is a solid. In this example, the silver chloride. Okay, and we've done a lot of those. Our net ionic equations and molecular equations, that we practiced this over and over and over again last unit. All right, the last type of reaction we're going to look at on this page is a combustion reaction. Okay? The key for combustion reaction is you always have the same 2 products. Combustion reactions always produce water vapor and carbon dioxide. It's even more specific than that, because what other thing is in common with combustion reactions? Yeah, one of your reactants is always the same as well. So 3 of the 4 compounds or elements in a combustion reaction will always be the same. On the reactant side, you always have to have 1 oxygen. On the product side, you've always got to have carbon dioxide and water vapor. These are your fuel reactions. Okay? Think about octane. Okay? A component of gasoline. This is the combustion reaction that occurs in your vehicle. Okay? You think about propane. If we live up in the mountains, we use propane to heat our homes. Okay? Propane goes through this reaction. If we live down here, okay, on the plains, or the foothills, we probably have a natural gas reaction occurring. Okay? Methane. Again, same type of reaction, okay, to heat our homes down here in the foothills. Questions? All right, last 2 types of chemical reactions here. We have complex ion and reduction in oxygen. I want to modify these redox definitions a little bit. So we're going to say compounds / elements. Well, let's say elements. Let me change this again. Ionic form gains to become more less positive. All right, the complex ion reaction up at the top there. The key to this one is to recognize that your product still has a charge. We would normally expect iron and the thiocyanate ion to combine together to make a neutral compound here, right? Given these charges, we would look at this and go, okay, this is the product that's going to get written here. Well, this is one of those instances where the compound that's formed isn't neutral. Okay? Most of the time in our world, we're going to combine ions together to make neutral compounds. But every once in a while, what we expect to happen doesn't happen, and we end up with a compound that still has a charge associated with it. And we call those types of reactions complex ion reactions there. Any questions about those? Yes? Complex ion, yeah. Just call it a complex ion reaction. All right, the last two types of reactions kind of go hand in hand. We're going to spend all next week working on redox reactions. They are oxidation and reduction reactions that are performed at the same time. Now, I modified these definitions slightly because it doesn't necessarily always have to go back to an element. Okay, you can have something that has one charge, gain some electrons to become less positive, and still have a charge associated with it. So, oxidation, element loses electrons to become more positive. Or reduction, it gains electrons to become less positive. It is very important that you keep these two terms straight in your head. Sutton uses the cheesy mnemonic device, Leo the Lion Gers. Okay? That's how I keep them straight in my head. Leo stands for loss of electrons oxidized, and Ger stands for gain electrons reduced. And that's how I keep the two terms straight in my head. Leo the Lion Gers, lose electrons oxidized, gain electrons reduced. And it's going to be absolutely essential when we start tackling redox reactions, the end of this week, beginning of next week, that you are comfortable knowing which one is which. Any questions for me?